quite in deep what actually are primary and super keys, but still I will give you a little bit of introduction because this is a very important topic. Okay, so what I am actually going to tell you is very much important. So just keep in mind to do not miss the class either if I am taking or Mohit sir is taking. Okay, so just keep in mind that do not miss this class. Okay, another thing is that ER is one of the easiest concept. I'll tell you about the cardinality part because if you understand the cardinality part, I will be covering the cardinality part. If you understand the cardinality part, there is not much there. Okay. So first concept here that we will be going deep in normalization part. Still, you need to understand there is a difference between these three components. Okay. So if you remember, I've already told you that in when we are designing a table. Okay. So I have to uniquely identify a row or a tuple or a record. Okay, so these three is one and the same name. Okay, so whenever you're reading a book, do not get confused if they're using tuple, row, or a record. So these three is one of the main thing. Okay, so you already know that what actually is these particular headers are referred to as, and headers, roll number, name, class, you already know that. Okay, so just let me also tell you a little bit of these things because I think they have already covered in the previous lecture. Just to remind you of the terminology, I'll just say that these things are referred to something called as entity type. Okay, so I think you have already covered this entity type and whatever entry is in it. So if one Ram and fourth class, two Sham and fifth class, this particular entries or the instances. Okay, so these entries are referred to as uh, entity. Okay, so these entries are referred to as entities, and the headings that you write on the headers is referred to as entity type. Okay, so there is a difference between these two. Okay, so if I have to uniquely identify any record or any person's record, I rely on this particular thing that is referred to as roll number, because I know that this particular roll number has uniqueness defined in this. Okay, so I can uniquely identify a record by using a roll number. You already know that if you have a your roll number that is assigned to a university, and every record that is associated with you will be accessed by something called a roll number, because the name can be same, but roll number is always unique. Okay, so in the similar way, uh, super key has the capability of uniqueness. Okay, so uniqueness. Okay, now I'll tell you the difference. It's a little bit confusing these terms, so just bear with me. Now if you do not understand, just let me know, I'll repeat it. Okay, so it is an important concept, it's very important concept. Okay, another thing is candidate key. Now it is saying that it is a minimal super key. Again, it has uniqueness in it, uniqueness, plus there is something called uh, minimal minimalism. Okay, again one and the same thing. I'll let you know, the difference. Okay, now another thing is primary key. Okay, so again it has the constraint of uniqueness. Again it has a minimal concept, and it has another concept that is not null. Okay, so if you are assigning a primary key constraint to any of the row, it means that you cannot leave the value null. Okay, so this particular thing can be represented as primary key. Every primary key is a candidate key or a super key. Okay, so every primary key is a candidate key and every candidate key is super key. Okay, so if you're seeing here, super key has the least of the conditions, it only require uniqueness. Candidate key has a little bit of a condition that it has to be a minimal super key. Okay, now primary key has one more condition added here, that is not. Okay, so there are another condition like reducibility, irreducibility. I'll just do not want to bore you with this one. Okay, so when I come to normalization, I will tell you definite properties of this. Okay, so understand the minimum part of this. Okay, so now what is actually a super key? So super key has a constraint of uniqueness. Now if you're seeing here the constraint, this particular roll number can be referred to as a super key. Okay, so there is no problem with that. Okay, another thing is that if I combine this roll number with the name. Okay, so this is again a unique concept. Okay, so roll number combined with the name is also a unique concept, so it is also referred to as a super key. It can also be referred to as a super key. Just let me take these examples. Okay, so I'll just take the example. Okay, so name, then roll number. I'm just taking a simple example, simplest example. Don't worry, it will be again covered, but still you need to know about this. Okay, so name, roll number, class. Okay, so one Ram, fourth, two Sham, fifth. Suppose if there is a repetition, three. Again, there is another person named Ram, and it is in sixth. And four, there is another person named Tom. Okay, so he is in fourth class as well. Okay, suppose these are the records that is related. So now I already know that roll number can be used to uniquely recognize any record. Okay, so I can say that roll number is a super key. Okay, so if I combine roll number with the name, okay, so with the name, I'm saying that these two columns can uniquely identify any record. Okay, so I can say one Ram. Yes, it can uniquely identify. And 3 RAM is different than 1 RAM because here it is 1 RAM. The one is different than this. These two entries are not equal to each other. So I can say that yes, I can use a roll number combined with the name entry, combined with the name header, and it can also be referred to as a super key. Okay. Again, if I use roll number class, again, this is also a super key because already roll number is already a unique constraint. Roll number is already a unique constraint. So combining it with anyone do not gather out its uniqueness here. Okay, so it can also refer to as a super key. Another thing is roll number class. Another super key that can be derived out from it is roll number class and name. Okay, so it is also super key. Another thing, if this is the table and if I can another combine 2 or 3 rows that can uniquely identify, that is also fine. Okay, so if I do not want to use roll number, I can use another combinations that should be unique. Okay, so if you're seeing here, suppose this is the table, only these are the entries in the table. These are the entries that exist in the table. This is not in any way generalized. Okay, so this is the complete table. I'll say this is the complete table. Okay, so from this complete table, I can easily see, because the entries are very less, so I can easily see if I combine name with class, it can also identify a unique entry. Okay, so name with class, because Ram fifth, Ram fourth, Ram sixth, Tom fourth, and Sham fifth. These are all different entries, and they are not collaborating with each other. They are not, but you say conflicting with each other. But if this provided that these are the only entries in the table, because there are only 4 entries, I can easily look out. Okay, but if I say that I say that name can uniquely identify this particular, say this cannot be a super key because the two names the names can be repeated. Okay, so this cannot be a super key, keep that in mind. Okay, another thing, can I say that class can be a super key? Class can individually use super key? No, class cannot be a super key because it is again repeated here and the entries here will be different. Okay, so if you're thinking on no, you cannot use the class name as a uniqueness concept, because in a class there can be many entries. Okay, so fourth class has Ram and Tom there, so I cannot use class to uniquely identify a record or a person. Okay, so that is why these are not super keys, but combined, if provided that this is a complete table, if I combined name and class, it is uniquely identifying any other entry in the row. Okay, so there may be other entries like address and other things, and address, roll number, name, class, address, and then what you say, your uh, test marks, something like that, fees that is related to each other, every other asset that can be identified. Okay, provided that is a complete table. Okay, so do not confuse this. There may be same person in a class. Okay, so in because in your class there may be two persons having the same name, but in this particular class, in this particular table, there is no entry, so that is why I'm denoting it as a super key. Okay, so we are seeing here there are so many super keys. First is this one, second is this one, third is this one, fourth is this one, fifth is this one. and sixth, this is not a super key, seventh is not a super key. Okay, so you understand it. Anything. Now what is actually a candidate key? So candidate key is a minimal super key. Minimal, one more condition, minimal super key. So out of these five super keys, which one is the minimal? So this is the minimal super key. So you can say that roll number is a candidate key. Simple. Roll number is a candidate key because it is a minimal. So it only contains one row. Okay. So this is simplest example. Okay. Another thing is primary key. So you can also refer to as a roll number entry as primary key. So it can happen that primary key and roll candidate key can be same, because if you're seeing here in this table, there is no null entry. So I can say that roll number can also act as a primary key. Okay, so candidate key can be more than one, but it has to be a minimal. Okay, so if you're seeing here, minimal means if there is another entry in the same table containing only one particular header. Okay, so suppose if name was unique, so name can also be referred to as a candidate key. Okay, so keep that in mind. But primary key can only be identified if you are given entries. Okay, so most of the time we will be entered with, we will be have to find out the candidate key, not primary key, because for primary key you have to know that if the table entries are containing null or not null, these kinds of. So you have to see the table entries before deciding anything is a primary key. So most of the time we will be finding out only the candidate key part. Okay, so these are the three differences between it. Okay, so that is why I've said that keep in mind that super key is the biggest set. Okay, so there is some little conditions here that minimal super key should be a candidate key, and there is one more condition that there should be not null there, and if there is a not null, then that particular thing is referred to as a primary key as well. Okay, so till here if you have any doubt. Okay, so primary key and candidate key is very much similar. So for primary key to extract out, you have to see the entries. Okay, so if there is, suppose if in the table 1 2 and there is nothing written here. Okay, so 1 2 4 something like this, roll number. Now if I just refine the example here, roll number, name and class. Okay, so suppose there is written name Ram, Sham, so Tom and Sam, something like that. Okay, first first second third. Okay, so if you're seeing here, there is no entry contained in the roll number part. Okay, so that particular roll number can be termed as a candidate key, but not as a primary key, because primary key should not contain any kind of a null entry. Okay, so roll number is containing a null entry. This cannot be referred to as a primary key. Okay, so that is why I've said for primary key you have to see the tables entries in the table. So that may not be possible in questions. Okay, so keep that in mind. That may not be possible in question. So most of the time in books also they will be always referring to something called a candidate key. Okay, so these are the three things that you have to keep in mind. Okay, so if you have any kind of a doubt, just let me know, because this is a very important concept. If you have any kind of doubt, let me know. Okay, so moving on forward, again this particular concept will be repeated in normalization part. Okay, so just I want to tell you this because there will be some key entries that you may have already studied in the previous part, in the previous slides. Let me see if there is anything. Okay, so if you're seeing here any key entry, here, phone number can be a key entry. Yeah, it can be possible. So you can, there is no let me see if there is, I think there is no key entry. Okay, so yes, if you're seeing here, this is underlined part. Okay, so this SSN. Okay, so again it is not underlined, but this social security number can act as your key entry. Okay, so in ER diagram we will use this as particularly key. Okay, so it is denoted by only by underlining any key particular part. Okay, so SSN can be used to uniquely identify any entity in the table. So keep that in mind, just keep that in mind. Okay, so key, I'm not talking about any candidate key. I'm not talking about any primary key, nothing like that. Okay, so just keep in mind, key entry means that it can uniquely identify. This is a general term that will be used in ER model. Okay, so key, it is most probably it is referred to as a candidate key, not primary key or not super key. It is mostly referred to as a candidate key. Okay, so if you want to go deep into it, you can. Okay, so this particular thing, SSN can be regarded as a candidate key because first of all, we cannot see the table entries here. There is no table entry, so I cannot say that it is a primary key or not. So I'm sticking with my candidate key part. Okay, so candidate key because it is only one particular what you say, one particular entry. And if you want to see the super keys, it can be SSN plus name, SSN plus name plus address, SSN plus name plus address plus D name plus D name. You already know. Okay, so still if you have any doubt, let me know or I move forward. Okay, so now this is again a very important, this is example of it. If you're seeing here, uh, student ID, because if you're seeing here, it can also be referred to as a candidate key. Okay, so you're seeing here only one entry, uniqueness is there, so it can be also referred to as candidate key. Roll number is also there, uniqueness constraint is also there, so it can also be referred to as a candidate key. And there is another thing that is called as email. Okay, so email can also be uniquely identified and record, so it can also be used as a candidate key. Okay, so primary key here, it is written as this one, student ID. So it can also be, you can know that every primary key can be referred to as a candidate key. Okay, so based on this diagram, I can say every primary key is also a candidate key. Okay, so you're seeing here, but every candidate key is not a primary key because you have to see a not null constraint for that. Okay, so in this way, in this particular example, you can say because only there are three entries and there is not one entry there that is null. So you can also say that this one is also a primary key. This one is also a primary key because primary key has only one constraint, that is extra constraint, that is not null part. Okay, so in this particular table, we can see that there is no not null. So candidate key and primary key in this particular table are same. Okay, so keep that in mind. Primary key and candidate key can be same. Okay, so most of the time, in most of the examples in any of the book you take, they will always say to find the candidate key, because most of the time we do not want to give entries to the students, because if we have a larger number of tables, like 4 or 5 tables in the questions, so I do not want to give the entries to you. So that is why I always want to say that find out the candidate key in these particular tables. Don't worry about that part right now. This is the example. There is something called the alternate key. So this particular, just reserve this particular part in the coming lectures of normalization. So I do not want to confuse you. Just for the time being, now you know three things: super key, candidate key, and primary key. Okay, so just forget about alternate key. Okay, now this is your relationship set. So I'll just start with the example. It will be more easier and clearer to you. Okay, so my style is just I give you a little bit of examples with key concept and I will come to the slide back. Okay, so just I'll give you an example. There is something called a relationship constraint. So I will be talking about cardinality. Okay, so this particular part, that one-to-one relationship, one-to-many, many-to-many. Okay, so in this particular part there are many examples. Okay, so I'll take one example and explain all the concept. Okay, in the example I'll explain all the concept here. Similarly, I'll explain participation and partial participation in the same example, and I'll also tell you about what is the degree of relationship. Okay, so don't worry about that part. So just one example, I'll cover all the concept. Okay, so it is very easier if you understand with the example rather than reading the theoretical part. Okay, so I'll just take one example. So in the example, the requirement analysis part, it is already given. Okay, so I think the example is already in your slide. If I can take the requirement part from the slide. Okay, so these are the requirement part, two requirement part. Okay, what is it? It is saying that there are two entities here. First of all, there are two entities. I'm giving you everything. So everything that comes under requirement analysis part is given to you. Okay, so two entities there. First entity is your employee, another entity is your department. Okay, so what is the relation? Relation is work. works for. Relationship is works for. You, I think you have already able to identify the these kinds of thing because you have already studied this in your previous lecture. Okay, still you have any kind of a doubt, let me know, because again this is a very important concept. Okay, so if you do not understand it, it will be difficult for you when I come to the conversion part. Okay, so convert any entity to a table, it will be very difficult for you. Again, if you are watching this in a recorded session, again you can post any queries on the email or anything. Okay, so just listen it very carefully, because that is why I've given you example directly. Okay, so suppose there is an employee, so this is employee, there are many employees there, so employees are represented like this: E1, E2, suppose E3, E4, E5, something like that. Okay, so these are the employee set. Okay, now the relationship here is works for. Now the employee works for department. Okay, so the department is this one. Okay, so there can be many departments again. D1 is one department, computer science department, electronics department, you can think it like that. Okay, so suppose this one here. Okay, so what is the requirement phase? It is saying every employee works for exactly one department. So figure out this part. Okay, till here it is saying every employee works for exactly one department. Okay, so suppose the employee works for D1, employee 2 works for, again it can works for D1, because again read the next part, and a department can have many employees. Okay, so if you take out logic, so a computer science department has many employees, and every employee of Bennett University is working in a department. So exactly one department every employee is working. So one department can have multiple employees, so that is also true. Yeah, there is no problem in that. So suppose E3 employee works for department, suppose department this one, electronics department, and E4 also works for uh, electronics department, so that can happen. So there can be multiple employees. Suppose E5 also works for electronics department, so it can also happen that in one department there can be more employees. Okay, so suppose E6 also works for electronics. Okay, so two employees are working in the D1, four employees are working in uh, D2. Okay, so again there is one other requirement analysis. New department may not have any employee. Okay, so suppose this is new department that is established in Bennett University, that is BCA department. So right now this is just a theory, it is not actually implemented, and there is no employee uh, that is related to this particular department. Okay, suppose. Okay, so that is why I've let this particular department as it is. Okay, so this requirement part will always be given to you, so you can design a particular relationship. Okay, so based on these statements I'm designing the relationship. Okay, till here if you have any doubt, let me know. Just unmute your mic and let me know. Okay, so these are the things that are already given to you. Based on the given things, I'm just designing a relationship. Okay, so now the first thing is you have to find out something called a degree. Now what is a degree? How many entity sets are participating in a relationship? Okay, how many entity sets are participating is called a degree. Okay, now this is your relationship, you already know this. This is your entity, this is your entity. Okay, so what is the entity? Entity is a noun. Okay, so what is a noun? A name of a name, thing, or you already know that in English, so it is a very easy way to remember it. Okay, so employee is an entity, department is also entity, and this is a relationship. Okay, so how many entity sets are participating in it? So entity set, this is one entity set, it is containing 6 entities. This is one entity set that containing 3 entities. Okay, so what is the degree of it? the degree is 2.
Mm.
Yeah.
Yes, sir.
Yes, sir. Please ask. Okay. Okay. If you do not have any doubt, I move forward. Okay. Now, employee and department are two entities set. So they are participating in one relationship. Now the degree of this particular, what do you say, this particular schema, the degree of the particular schema is 2. Okay, so it means that there are two entities that are participating in one relationship, that is referred to as bonus. Okay, another thing is referred to as cardinality ratio. Cardinality ratio. So don't worry, everything is written in your slides. I'm just directly telling you. Okay, so there everything is written as theory part. So I'm just giving you a direct example so you can easily understand it. Okay, so now what is a cardinality ratio? The maximum number of relationship. So these are not actually these are informal, what you say. You can also look at in your books. These are the formal definitions also. So I'm just writing it in a simpler way. Okay, so maximum number of relationship ship ships ships in which a entity can participate, which a entity, now the keyword here is entity, can participate. Now what is the entity? Entity is the entries in the entity set. Okay, so this particular circle is the entity set. The inside entry e1 e2 e1 e2 e3, these are entities. Okay, so now this particular I have to find out the maximum number of relationship a entity can participate. Okay, so from employee set you can easily see from employee set what is the maximum number what is the maximum number of relationship employee can participate. So e1 can participate only one relationship, e2 is also participating in only one relationship, that is it is working for a single department. E3 is also participating in one relationship, E4 is also participating in one, E5 is also participating in one relationship. So the maximum relationship the entities can participate is only one. Okay, so I'm saying from M side the maximum relationship the entity can participate is one. Okay, so from the department side you see. Now here, if you're seeing here, the department D1 is participating in two relationships because it is taking two entities. Two entities are working for this department. So if you're seeing here, there are two incoming lines. Okay, so it means that department D1 is has what do you say maximum participation. Maximum participation means it has two. Uh, uh, the cardinality of this particular D1 is 2. The cardinality of this particular D2 is 1, 2, 3, 4. This is D1 is 2, D1 is 4, and D3 is 0. Okay, so the D3 is not participating in it. Okay, so what is the maximum here? It is 4. So do not write 4 there. In place of 4, if anything is greater than 1, you can write n. Okay, so if anything is greater than 1, you can directly write n. So from the department side, it is saying that department can participate in multiple relationship. Okay, why the multiple relationship? Because two employees are working in the same department. That can happen in computer science department. There are multiple employees working. Okay, so from department side, if you are thinking about from the department side, the maximum number of relationship is whatever is the number of employees in a department. So I do not know what are the number of employees. I'm just directly saying it is more than one. I will say n. Okay, so till here if you have any doubt. Okay, so D1 is participating in more than one relationship. D1 is participating in more than one relationship. Just see from this incoming lines. Okay, so the cardinality of the department is n. Okay, so sometimes they denote it with lower n or you can use upper n. There is no problem in that. So this is just a denotion part. Okay. Okay, so now the third part is participation slash existence. Okay, So it is just reverse of whatever cardinality ratio is. It is just minimum number of relationship in which an entity can participate. In which a entity can participate. Okay, so if you're seeing here, what is the minimum number of relationship? E1 is participating in one relationship, E2 is also participating in one, E3 is also one, 4 is one, 5 is one, and 6 is one. Okay, so the minimum number of relationship that every entity is participating here is one. So you can say from the emp side, the minimum relationship part is one. From department side, now see, this is interesting. Now from the department side, the D1 is participating in 2 relationship, D2 is participating in 4 relationship, but D4 is participating in 0 relationship. Okay, so what is the minimum relationship from the department side? It is 0. Okay, so from the department side, you can directly say the participation from the department side is 0. Okay, till here, if anybody has any problem, we understood what is the degree, the number of entities, that is the degree of the degree, cardinality ratio, the maximum number of relationship in which entity can participate. Participation is different, just reverse of it. The minimum number of relationship in which an entity can participate. So 3 definitions we have already done. Still, if you have any doubt, let me know. Okay, we know. I'm just writing a relationship here again, just copying and pasting, so do not get confused here. Till here, I'm writing everything that we have known till now. Okay, works for employee, department, D3, E1, E2, E3, E4, E4, E5, E6. Okay, so there are 6 relationships, 6 employees. Okay, so now we'll know that the participation from the employee set is 1, minimum number of, and what is the cardinality? Cardinality from the employee. Keep that in mind, the cardinality that you have studied in your set theory, it is different than in that we will study here. Okay, so in set theory, you may have heard the number of elements in the set is the cardinality. So the cardinality of this is 3. So do not confuse that with that one. Okay, so here the maximum number of relationship in which we are in which a particular entity is participating is referred to as cardinality. So do not confuse this set theory with this particular DBMS part. Okay, the cardinality of this particular department is the maximum number of relationship is n, and the participation is minimum number of relationship is 0. Okay, so till here we have done till here. Okay, so now you can easily represent this in a simpler notation. How can you represent it? You can use this box. Now this is one entity. That entity is referred to as employee. That relationship is represented by a diamond. You already know that. I think you have already studied. Okay, so diamond, and then there is something called a department. Okay, so this relationship is works for employee, works for department. So the cardinality, now I'll show you. Just see here, there will be something going on here. If you do not understand, let me know. Okay, so cardinality here is 1, cardinality here is n. Okay, so now what you have to do, you have to write n here, reverse it. You have to write n here and 1 here. So this is referred to as 1 to many relationship. I'll show you how. 1 to many relationship. What is the meaning of it? That n employees are working for one department. Okay, so from both of the side, you can easily able to see that n employees are working for one department. If you're seeing from left to right, now if you're seeing from right to left, left to right, if you're seeing from right to left, now it is saying that one department can have many employees. Okay, so one department can have many employees. Okay, so keep that in mind. The cardinality works like this. Okay, so the ratio of cardinality ratio is referred here is n to 1. Okay, so this is a 1 to n relationship. Sorry, you can use n or you can use m, there is no problem. Okay, so this is one to many relationship, one to many relationship. So with the definitions of participation slash existence, with the definition of a degree, with the definition of a participation. Okay, so now there are again two types of participation. Again, there are some things that you can again add more details into this diagram. There is two types of participation, that is total participation and another is partial participation. Okay, so two types of participation. Now, how can you represent it in a diagram? I'll tell you about it. Don't worry about it. Okay. So now, understand. I'll just simply give you a definition. Simple in simple terms. Okay. So if all the entries, if all entities of entity type participate in a relationship, simply simple definition, participate in a relationship. Okay, so it means that if every entry is participating in a relationship, that particular relationship referred to as a total participation. Okay, so another thing is that if you're seeing here, all employees are working for a department. So this particular relationship is referred to as a total participation from the employee side, because if you're seeing here, every employee is working for some department. Okay, so that is why. Now, how can you represent this diagram more detail? So this is a total participation. So total participation is referred by double lines, and partial participation is referred to by single line. So what is a partial participation? That the reverse of a total participation. Okay, so if any entry is not participating, if a single entry is not participating in a relationship, that you can refer to that particular thing as a partial participation. Okay, so it's as simple as that. Okay, so I'll write it so you can easily understand it. If at least one entity do not participate in a relationship, then it's a partial participation. Okay, so it is denoted by a single line denotion and it is denoted by a double line. Okay, so if you see here, that if I again draw the diagram here, so every employee is working for department. Every employee is working for some department. Okay, so it means that there is a total participation from the employee side, because uh, every employee is participating in the relationship works for. Every employee, you have already seen there are 6 employees, they are all participating in the relationship works for. Okay, but from department side, there is department D3 that do not have anything, because there is a new department and we have not have any entry related to that department. Okay, so D3 has not entry, so it is a partial participation. So that is why there is a single line. Okay, so again, there is another representation. This particular representation is also referred to as cardinality ratio. So I'll write it. Okay, so this D3 is not participating in a relationship. This particular representation is called single line double line representation. There is another representation name that is referred to as cardinality ratio. Okay, so both of you can use both of the names. Okay, so cardinality ratio, where n to n is given, this is referred to as a cardinality ratio, and single line double line can also be used because we are using total participation and single uh, partial participation. Okay, so here this is a total participation, from here this is a partial participation. Okay, there is another representation also. Other representation is referred to as min max representation. Okay, another representation, very simple, min max representation. I'll show you how to represent min max terms. So you can easily design the same thing, employee, then there is a relationship works for, okay. So now works for department, and then you can use what is the minimum number of relationship in which employee is participating. If you remember, minimum number of relationship, every employee is participating in at least in exactly one relationship, that is works for. So minimum is 1. What is the maximum employee is participating? It's also 1. Okay, so it is just like the participation or cardinality. Okay, we already know cardinality is the maximum number of relationship in which an entity is participating, and participation is the minimum number of relationship in which an entity is participating. Okay, now you can say 1 comma 1 here. Okay, another thing is what is the minimum number of relationship in which a department is participating? That is 0, because one particular department D3 is not participating in a relationship, but is the maximum is more than 1, so you can write n here. Okay, there is no there is no need to write a single line, double line here, because it is already represented by this particular min max representation. Okay, so keep that in mind. More information is represented in terms of min max representation. Okay, so suppose if there are in the requirement analysis there is some requirement that two two employees should work two employees should work in different departments, something like that. Okay, so suppose a single employee should work for two departments. Okay, so from CS also, this particular employee should also work for electronics as well. Okay, so if in a requirement, if there is something that you can also see that the minimum relationship in which a particular employee is participating here is 2. So this particular will be represented in this one. Okay, so that is not possible in this particular notation. Okay, so this particular notation, this min max notation have more information as contrast to this particular representation, that is single double line. Okay, so most of the time this particular representation can be used is used in books, but this is also another representation that can be asked, so keep that both the representation in your mind. Okay, okay, so till here if you have any doubt, let me know. Now the next part has to be done by you, so I am giving you the requirement part. So the relationship we have till studied here is 1 to many. Now the relationship we will study here is 1 to 1. Now I'm giving you the requirement part. The requirement part is every department should have a manager, and and only one employee manages a department. Okay, so maybe this is one. Another that is given to you: an employee can manage only one department. So these are two things that is already given to you. So based on these two things, you have to design a relationship. Okay, so the relationship can be, suppose this is your M. The relationship can be manages. Okay, so you can pick out any name. So I think manages is more. You just understand this, but you can pick out any name. So manages is more appropriate here. So that is why I've used manages. Okay, you can use any relationship. So now every department should have a manager. Okay, so it means that it is just saying that every department should have a manager. So it means that D1 should be managed by at least one employee, exactly one employee. Okay, suppose D1 here, it is managed by one employee, that is E1 here. D2 here should also be managed by another employee because it should have a manager, so it is represented manages by 2 1. Then there is another employee that is managing department D3. Suppose there is department D4, so there is another employee that is managing D4. Okay, so now and only one employee manages the department. So that is true because only one employee is managing a department from this side as well. Now see, now what is the next condition? The next condition is that employee can manage only one department. I think that is already clear from the first part. Okay, so again from this, an employee can manage only one department. So there may be some employees that are not managing any department. Okay, so because this is an employee set, there is no compulsion here that the this is an employee set. This is not a set of all manager sets. Okay, so there may be some employers that does not manage anything. Okay, so E5, E6, they are not managing any department. So they are simple employees. So simple employees like us that are working in a department. Okay, so understand from this points, every department should have a manager and only one employee manages a department. Okay, so this is a total employee set. So this is total employee set, not the employees, the set of only managers. Okay, all the employees set. Okay, so now an employee can only manage one department. So what it means is that from here only one employee can manage the department. There may be other employees as well that are not managing anything. Okay, so from here you have to find out cardinality, you have to find out participation, you have to find out degree. Okay, so degree, tell me everything in the chat box, so I'll again let you know. If you have any doubt, let me know, and just reply in the chat box. What is this cardinality from the employee? What is the cardinality from department? What is the cardinal participation from employee? What is the participation from department? What is the degree of the relationship? Okay, tell me now. Okay, so well done, Harshita and Abhishek. For now, degree is two, yeah, definitely, because there are two particular entity set that are participating in a relationship. Degree is two, yes, absolutely. So I think you already know the answer. It's very simple. Okay, so I can directly write it now. So degree here is 2. Yeah, absolutely. What is the cardinality? Cardinality is the maximum number of relationship it is participating. So maximum is 1. What is the participation? The minimum number of relationship it is participating. So minimum is 0. Okay, similar way, this department maximum number of relationship it is participating, it is 1, and the minimum also, the participation part is also 1. Okay, so if you want to represent it in a single double line, total participation and single double line representation, how can you do it? So for single double line representation, this is your employee, this is your relationship manages. So I'm just writing it manages, so you can just tidy up here. I'm just that writing it roughly, you can understand. Okay, so now what is the relationship here? So from employee side, uh, one particular employee 5 and employee 6 is not participating, so this is a partial participation. But from department side, everyone is participating, so this is a what you say, uh, total participation. So you double line here. So now what is the relationship type? So you write cardinality here. So cardinality here is 1, cardinality here is 1. So you reverse it, 1 is here, 1 is here. Okay, so it means this is 1 to 1 relationship. Now what is the meaning of it? Every employee manages one department, and in every department should have one employee. So I'll write it so you don't get confused. So always write these kinds of things. Okay, so every employee manages one department, every department should have one manager. Have one manager. So this is your one-to-one relationship. Okay. So if you want to represent it by using different, so this is your single line, double line representation. If you want to represent it by min-max representation, so show me min-max representation. Just draw it and share your screenshot with me. So what is the min-max representation of this particular diagram? Show me. Okay, so I think if you do not understand it, so understand it from here. I think it was very easy. Nobody is able to share the screenshot.
I shared a screenshot.
Shared it? Yes, let me see. Okay, so it was not updated. Yeah, absolutely. Absolutely correct answer by Harshita. So good, well done. Okay, so now you can directly say, you can write min-max representation like this one. So I'm just writing it so you understand. Again, if you have any kind of doubts, just let me know. So minimum relationship in which an employee can participate is one. Maximum I think minimum relationship it can participate is 0. Maximum relationship in which can participate is 1. Okay, so Arshita, I think you made some mistake here. Okay, so here it is 0. Minimum relationship, min max representation. Okay, so employee can participate here. If you see here, this two employees are not participating in any relationship, so you write 0 here and then 1. Okay, another thing is that you already know, so minimum
Sir,
relationship in which, yeah.
I had written maximum and minimum.
No. You have to write minimum and maximum. So this is the
Okay, sir.
notation. You cannot change it. Keep that in mind. Okay.
Okay, sir.
If you change it, it will be wrong. So just keep in mind it is just fixed here. So first you have to write minimum, then maximum. Okay. So if I give you any question, you write max min, your marks will be cut. Keep that in mind. It's very important. Okay. Okay, so only one relationship is remaining, that is many to many. So I'll again give you an example so that you can easily understand. Okay, so in the PPT, if you read about it, everything that is we have done is already given. So this is for your own reference. Okay, so I'll go one by one with every. These are the participation constraint that will be you understand it completely. Okay, so these are the examples that are additional examples that are given to you. So I'll again tell you each and everything about it. Okay, so there are two relationship remaining, that is many to many, and then there is a recursive relationship. Okay, so I'll tell you about it in the next one. Again, if you have any kind of doubt, just you know what to do. Okay, don't hesitate to ask. Okay. So thank you for listening. You can move on to the next one.